I'm just going to set it.
Okay.
Unless you want it over there.
No, it's not.
Right there.
It's great.
Morning, guys. And lady, how are you? She walked in as I looked up and saw that it wasn't just guys here. Welcome to our monthly meeting. Not a whole lot to go over. Sorry about the parking, but you know, it comes with the territory of construction. And it's actually, as you saw coming in, it's really busy up there. So normally it's not this bad, and hopefully next month it won't be. Anybody here besides myself job hunting?
Still?
Yeah.
Gotta talk
now. It's my unique situation that makes it harder for me. Not many people will let me do what I need to do for family. How many people here work for companies that are looking for people? All right. After the meeting today, if you guys want to come up over on the side and get together, and maybe one can help the other, and somebody can find their job, a brand new job. Outside of that, there's not a whole lot. So I will go ahead and turn it over to Mark to introduce our speaker for this month.
Thanks, John. Good morning, everyone. My name is Mark. I'm co-chair with John and our free agent Peter as well. So I've known Roger from another group, as is ASIS. They're a physical security group. Guards, gates, guns, fences, and all that good stuff. But I think there's a wide overlap with IT and physical security, and I've seen this presentation several times and at various audiences, and it's always been exciting and interactive. And I know this group is very interactive, so we'll probably go till at least noon on this one. And it starts off with the basics and it gets really advanced, and I hope you enjoy. With that, introduce Roger Rohr.
Hey, Mark, thanks. Good morning. Good morning. Just a little bit about me and what I am and So I'm actually more of an access control identity management person. Currently, I'm the director of identity management at IST, which is an access control integration. Our company actually started out at DOE, and to Mark's point, we were actually a combination of two companies. We were IT services contract for DOE, and then we were physical security, and then we became very clear to the owners that they needed to merge. My background's kind of similar. I was started off as actually an access control installer. In 2001, I went to State Department when they were first using smart cards with physical access. I have been sort of on the ground floor moving up with identity management and using smart cards with physical access. Used to chair the Smart Card Alliance Physical Access Committee. And then about 9 years ago, I got a call and they said, how would you like to transition the physical access system at the Pentagon from magstripe to smart cards? And I wasn't stupid enough to run away, and I spent 9 years there doing that. Also, while I was there, got into biometrics quite a bit. So we're going to kind of, like as Mark said, start off basic. This is actually a review course for, we did for the local society chapter of the American Society of Industrial Security. A couple of references that I like to list here, and I can give you copies of the slides if you want. The first one is the true physical security is just this implementing physical security. This is put out by American Society of Industrial Security. It was recently revised, and it's actually pretty good. Up until this time, their stuff was kind of weak, to be quite honest. Second one is by Wiley. It's the Security Engineering book. This is just a real fundamental, hey, get you think about security and attack vectors. It's really not even specific to physical security. I think it's a great book. I really enjoyed actually reading that one. Just like physical access, we're looking at, or excuse me, just like logical access, we're looking at the three factors: something you have, something you know, something you are. And at the end of the day, you know, whether it's physical or logical security, it truly is about access, right? If you can't access the asset, it's not worth having. You know, if you think about it, we got nuclear weapons sitting in sunken submarines at the bottom of the ocean. You cannot access them, so it's not really an asset. I mean, I don't know of anything that we want to protect more than a nuclear weapon, but yet we have those things sitting there free for the taking. The one primary difference, I will say, between physical security and logical security is life safety. We always get trumped by life safety. We always have to have a way to egress the building. There was kind of an interesting story. I don't know if it's truly true or not, but it kind of makes sense. And it was one of these three-letter agencies got a new lease space. They actually put a vault door in the front entrance. Fire marshal came in and said, "Hey, take that out. You can't egress it." They said, "We're, you know, XYZ. They put a couple guys with some machine guns up there." He says, "Fine." Goes to the building owner and he says, "I'm shutting off water to the building and you're not allowed to occupy it." Life safety will always trump the actual security. You have to be able to get the people out. So the first thing to talk about is the real basics is a lock. And, you know, a lock is a mechanical thing that basically, like this one, it has milled sides that expands and contracts, basically some sort of a lever that keeps that thing from unlocking. The most basic first kind of lock we have is this. It's a warded lock. There's actually no mechanism, no secondary mechanism that's keeping that trip from being undone. This is why you see things like skeleton keys. And this is the basis of any lock. Here's the lever that you just trip to open it up. In the old days, master used to say, "Oh, look, you can shoot through it, nothing happened." That's because there's nothing happening in the middle of the lock. The lock's body absolutely serves no purpose other than to inhibit different wards. If the key isn't, and this is wards on it are different, that's all it did. It just kept the key from turning. There was no actual kind of secondary mechanism. The most common thing that we deal with today, and that's kind of a secondary mechanism, is a pin tumbler. So what happens is the key comes into the keyway, and these are the bidding pins, and these are what they call the driving pins. So that the key comes in and it lifts the bidding pins to the shear line, and that's what allows the cylinder to rotate, and that trips that primary kind of locking mechanism. So that's how a pin tumbler works. Now if you notice in here, there's actually another third pin here, that little red pin. Anybody got an idea why that red pin's there?
Master key.
Yep. It actually provides a second shear line so that you can have two different heights on that key, so that you can actually have a master key and then you can have a unique local door key. There was one thing they were talking about, oh, okay, the pins are, if you got more pins, you got more security. You really don't. The reason you'll see in commercial locks usually 6 to 7 pins versus like your home lock is 5 pins, is so that they have more options on master keying. If somebody can defeat a 5-pin lock, they probably can defeat a 7-pin lock. It's really about that ability to get more options so that they can master key something. I want to also say, this is your guys' presentation, so if you got a question, just stop me at any time and give me that question. We'll get it done. You know, if it's coming up further, we'll talk about it a little further, but feel free to stop me. Make sure you get what you want out of this.
So can you explain a little bit more about a master key? I mean, I'm sure we know basically what it is. But
sure.
How does that actually work?
Okay, so right now what you see is the regular key right here. You see this pin here? How it's got a drive pin. This is the master keying pin, and this is your bidding pin.
Yeah.
So this is the shear line. Think about this lock rotating like this. This is how it unlocks. This is the trip that basically goes in here to deactivate this lever to let the lock go out. So this has to rotate, but this cannot rotate because if the key's out, these pins drive this down and it keeps it from rotating. This is at the shear line. Now the master key will actually be cut down to here so that it's at this shear line. That's the master shear line. So both of these two pins will rotate in the tumbler. Is that making sense?
So is it forcing all the other ones to line up?
Yes. All the bitting will be the same on these as it is. So basically, let's say this is why you need, say you have like 5 unique keys for a facility, or 5 unique locks. This step right here will be the master key, and then there's about, basically you can make these cuts 5 different heights. So each door in that facility will have a different cut. These in this case, this is what, a 6-pin? These 5 pins will all be the same at all the doors. It will be just this cut on the key that determines whether it's a master key or a local key. And then for each door, they'll have a different height pin right here. And that way they keep the shear line for the master key the same by using, and they have different height master pins and shear pins. And that way you can recut it. And there's actually, this gets pretty complicated as you can imagine because they're usually not just doing one chamber, they're doing multiple chambers. And the lock manufacturers provide software on how to master key, grand master key, and you basically calculate it all out that way. But that's the mechanics of it.
Out of curiosity, when we bought a new house, one
Yeah.
of the things we did right after we moved in was we put in our key and it disabled the master key that the builder had used.
Yeah.
How does that work? I always wondered how it decoded a key the moment.
I'm trying to remember, and I haven't dealt much with that lock. There's actually, I believe there's a set of pins that actually drops out and gets pushed out. Basically the back of the lock is the way I understand those. I'll have to look at that, but I'm not absolutely sure, but I think that's how it's done.
So with the one pin, with the one cylinder, whatever, what do you call it again?
So this is basically, this is the well, the whole thing's the cylinder. This is basically excuse me, this is the core, excuse me. I'm not a locksmith, so I just play one at talk shows here. This is your drive pin, master pin, and bitting pin.
So if you had the one with the 5 doors and you had 2 sets of keys, you could probably figure out what the master is, knowing that.
Okay, so there is a method, what's called impressioning, and actually what you really want to do on your master key, you prefer to have it below, but because there is a thing called impressioning. Yeah, if you got all the keys, you could probably figure out which one is the master pin. If you had like all,
With your example, you said the only difference was that pin in the middle.
Right.
And so you could compare 2 keys.
Right.
And just play with every combination.
Right.
Right.
Right. And even, because one of the manipulation methods is to take a blank key and then you actually file it down until it stops making a mark, and that's called impressioning the lock. So yeah, you could, the other thing you could do if you're going to attack something like this, is say you're going to attack a commercial building, is you would actually impression your first lock. You would most likely get your top and then keep impressioning, and you probably could work your way into a grand master key. Yeah, that is an attack vector.
So inherently, these are not secure.
It's a relative, all security is relative, right? It is a relatively secure thing to do. And having tried to pick pin tumblers, I've never been successful at it. It was funny, I had a locksmith, I was saying, hey, what's the trick to it? And he goes, it's all about feel. He says, I'm not good at picking locks. He goes, but my mom is, because she's a dental technician, so she's used to using the tools and having the feel. So a lot of, manipulation techniques, because it's all done blind, is about how good your feel is.
I've read that some locks have like magnets in it also, and maybe side ones. Are you going to get into that later?
I don't really talk about it. I think what you're talking about is like the Medico sidebar. I have some Medico locks, I can show you that. And basically what the Medico lock does is it actually lifts and turns the pin, and then the sidebar goes in. And the idea, because the classic way you pick a lock or impression a lock is that you lift the pins and you put tension on it until you feel it hitting to where it goes free. So yeah, there are, and UL even lists them, there are manipulation resistant locks. So yeah, you can go to that level. You got to realize that, does this become the weakest tack vector, If it's not, and classically people break something else before they try to manipulate out the lock. Where you get a lot more worried about manipulating the locks is where you're worried about like classified information, where you want to know if it's been breached. It's almost more important to know it's been breached than to prevent the breaching. So sort of its cheap cousin to the pin. Did I get everybody's questions? Yeah. Cheap cousin to the pin tumbler is the wafer lock. Where do we see wafer locks all the time? And basically wafer lock is, instead of pins, we use these cheap sheet metal wafers. Anybody got an idea where we put them? Huh? File cabinets. What else do we really care about when we don't put good locks on?
Cars.
Huh?
Cars.
You see them in cars. How about server racks? Almost every server rack has a wafer lock on it. It's one of the cheapest, easiest to pick. I can pick wafer locks. It's the only lock I can pick. One time a guy in the office had a bet with me, and I picked it open with a paper clip in my pocket knife. They're easy, they're cheap. They're, keeping the honest.
Why are they easier?
Because the tolerances are really loose on them, and they're because you don't have to get on the pin like you do here. You can just bring something through. Because the tolerances are really easy, you can just put a little tension on the lock and you just rake it. You don't even have to kind of manipulate it. You just keep raking it out.
So like in the old IBM PC where we had the lock on the cabinet, which is basically the same key in all of them?
Yeah.
Was that different? Or I thought they were very the same. Like you could have different vendors' racks and the same key would work.
Yeah, I mean, there's you find a lot of the like utility locks, the manufacturers have kind of standardized on a standard key. And a lot of those locks are wafer locks. The other place we see a lot of wafer locks, alarm panels. Almost every alarm panel I know of has a wafer lock on it. But we put a tamper on there so we know we're getting busted into. Okay, lever lock is basically, instead of using pin tumblers, we actually manipulate a lever to a shear line. You don't see these much here. These I used to think weren't, are kind of old. You'd see them in safety deposit boxes, classically about the only place in the U.S. you see them. They're actually pretty good. They're really, especially when you get to stuff like this, what's called a double bitted. Because you actually have to maneuver the wafer. It could go either way, and you have to get it dead center to get it in. It makes it very hard to manipulate. See them a lot on European safes. It used to be the European classified lock. Safe lock was a lever lock. It's because you make them very thin, you put a spring on them, it makes them very hard to pick. The other thing you'll see here, you see these teeth on that? It's the classic thing to do on when you're picking is to put pressure on it and see if you're getting it to move into the latch. That latch will actually, those teeth keep you from doing that manipulation. I have one here if you guys want to look at it. And that's what makes it another anti-manipulation. So they're been worked on, and those are very secure lock is the lever lock. I just don't see much of them here. Kind of what we use, it's very similar to a lever lock, is a combination lock. And then basically it has these grooves in here. This gate falls in here, it retracts the bolt. So again, small mechanisms keep locking to bigger mechanisms. So this basically keeps this from being retracted. That's all that locks a safe. Usually then you have that go into like a big steel will that actually retracts the bolt. And what you do on the handle to keep somebody from because early on what people did, they just took a hammer and used the wheel to shear this off. So now they put it like a cotter pin shear pin on those handles. So even though you see the safe with the big wheel, you can't put too much pressure on it because you'll actually shear the shaft of the wheel and then you can't retract the locking bolts. So, you know, it's basically, as much of this stuff is, you know, it's design and counter design that we see. I don't know if you all seen the old round vaults. Got any idea why they're round?
They take pressure.
Fewer weak points.
It's actually, it's easier to make it mate to the frame. They would actually drop the door in and lap it like they do a cylinder on a valve. And the old safe Yankees used to boil dynamite and put a clay dam around the door and then flow nitroglycerin and blow the bolts that way. So the whole reason for round doors is that they can be lapped in, made very tight so you can't flow enough nitroglycerin to blow the bolts. These guys are inventive, you know. They know what's on the other side of these things. Okay, electrified locks is basically, you know, we start off pretty simple. You start off with basically like deadbolts and you put a solenoid on them. I see people taking pictures. I'm more than welcome to give you guys the slides, you know. So
Yeah, well, I'll post
yeah.
at least the location for them.
Yeah.
You know.
So, you know, basically a electrified version, a solenoid driving a bolt. I'm not a big fan of these because they seem to always be putting aluminum door fronts. Aluminum door fronts always expand and contract with the summer and the winter, and they always seem to get out of whack, but architects love them. So that's the other one we always have to fight with. Architects don't like big, heavy locking gear. We like big, heavy locking gear, so sometimes we have to make compromise.
So what's the benefit of electric?
Electric bolt?
Yeah.
Main benefit is it's architecturally, when it's retracted, you don't, it's not very obvious. It's much more of an architectural thing than it is a security thing.
So it looks pretty.
It looks pretty. Because this is basically recessed in the top of the door usually, and it just drops down. So when it opens, it doesn't, like a mag lock, they don't like the mag locks. A lot of architects don't like having something like a mag lock hanging down from the door frame. I like the mag lock because it works, it's simple. Fire marshal likes the mag lock because it doesn't bind. That's another issue with these. If you have enough air pressure on the door, it will actually bind the lock, and the solenoid can't retract the bolt, so you have to like read your card and hold the door in to get it to unlock. Or sometimes you have to read your card and shake the door to get it to unlock because it's bound up, and it's usually by air pressure from the HVAC system.
Roger, I heard you mention fire marshal, and I've heard you mention in past presentations that from jurisdiction to jurisdiction, the fire marshal is your biggest hurdle.
The fire marshal is always your biggest hurdle. Life safety always trumps security. It really is. And it's even coming now. We'll talk a little bit about it in skiff locks. You even have to have single path egress. Yeah. Electric latches, similar to the deadbolt, the biggest difference is these are designed to be mechanically, you can shut them so they have a bevel, but the other disadvantage of them is they can be manipulated, so you can get in there and pry them open because they have that same, you can lock it and latch it. So you see those mostly on like cabinets and stuff like that, not usually on doors. Strikes, this is pretty much the classic reset, yeah.
So when you say electrical locks, are they being driven by AC power or battery back with battery?
So
backup,
usually
or-
an electrical lock, and we'll talk a little bit more about access control as a whole, is driven off an an access control system. You know, sometimes it's just a standalone lock, like the secretary, hey, you can reach under a table and buzz you in. But most of the electric locking now is for access control systems.
So are they going to fail open and if you cut off electricity?
So there's two types of locks. There's actually what's called a fail secure and a fail safe lock. Fail secure lock, as it sounds, fails locked. Fail safe lock actually unlocks so that you can egress it. Even on a fail secure lock, it will have a mechanical egress out. So it just basically don't let you in. Particularly where we see you need fail-safe locks is on fire stairwells. Because once the fire alarm goes off, you have to be able to egress the stairwell on any floor. Because the theory is, hey, if you're going down to a certain floor, you can't get any further because of smoke, you need to be able to get out on that floor, go to the other stairwell. There's always two paths of egress out of any commercial building. So they always want that. It's okay during normal operations not to be egress from the stairwell into the space, but it's not okay during fire. The other one that we see, again, this is where you see security, and this is quite often why you see your stairwells in your elevator lobbies. This becomes a real problem, is when you get off the elevator, you have to have two paths from the elevator to two different stairwells. So that's a big security design. Sometimes we even have to go as bad as we just put the egress locks, you know, 15 seconds and you're into the space, the customer space. Because you have to provide that egress to two stairwells at all times. So strikes are primarily used on retrofit situations. So the door is actually locked. This just allows the strike, the latch bolt to come through it when it's unlocked. This is classically what we do when we haven't planned it out, is you just put a strike on there. And then at egress, your life safety egress is just the mechanical egress of the lock going out like you normally have, or the crash bar in some cases.
This is also good for buzzing, if buzzing someone in.
Any of them are good for buzzing people in.
Okay.
Yeah, they're all electrical locks. Any of them are good for buzzing people in. Yeah, it does make a noise. You'll hear the solenoid fire. But you'll hear a solenoid. Like, okay, so here's your electrified mortise set. This is what I prefer. The electrified mortise set on the left here, your left. That's got an actual solenoid in it. It's a good sized solenoid. That's what makes it why I prefer it. This is classically what you see in like a hollow metal commercial door. So the mortise lock is on the left, and you'll notice that it's got this big mortise that sticks the lock in, and then you actually insert the handles through this. This is what's called a knob set. So you have like a 2.5-inch hole bore through the door, and then just like a little 1-inch for the board. Problem with electrified handles is there's a very small solenoid in there. They tend to get really hot, and I don't like those. So this is sort of my preferred solution right here, is the electrified mortise set. The other thing that we can do on that is we can actually include a sensor, which is called request to exit. So when you turn that handle down, we can shunt the alarm on the door as you go out. Classically, what we do with these is the door is cross-drilled. We got a cable path, and then there's an electrified hinge that transfers the current and the sensor technology back to the door frame. So if you're doing new construction, that's certainly the preferred solution. But once you come in, it's a very hard thing to retrofit, because you actually have to modify the door, the hinge, get on the other side of the frame, and then run cable up the wall. So it's always better. And even if you're not sure you're going to do this, if you're doing new construction, have the door prepped for an electrified mortise set. It always That will save you a lot of money and headache, and if you're ever getting into a point where you're speccing new construction, that would be something I definitely recommend. Okay, mag lock. Like we were saying, great lock, really no moving parts. Fire marshals love these because it holds, and then when I release the current, it goes. So I can have a whole, I can have a horde of people like this. I'm pushing against this door. Once I release that power, I don't have to worry about anything, any kind of shear like a deadbolt that's getting bound up. I don't have to worry about anything binding on these. Also, it gives me a lot of flexibility because the door normally stops on this. So if it expands and contracts like an aluminum diaphragm, and it can, obviously it can do some of this kind of shifting up and down. Probably the biggest single thing on these that goes wrong is they get dirty, and if they, particularly like in factory areas, if they get enough metal filings on them, that will actually have enough to actually stop them from binding. That's about the most I've heard as problems. Sometimes installation will have a little bit of problem. That's more your installer's problem. You have MOV, too many MOVs. Sometimes manufacturers' access control systems put MOVs on their lock relays, and then the lock company puts an MOV in the lock, and then that causes your problem. You can only have one MOV. But once they're installed and working, the only thing I've really heard is problem is dirt.
What is an MOV?
Metal oxide varistor. It's basically, that's what's basically the circuit component that's a surge suppressor when you buy a strip, power strip. If you look in there, it's like a little lollipop of some metal oxide. I'm going to get the acronym wrong, but it's basically a surge suppressor.
So an attack against that would be iron filings.
It could be, but you're going to know that it's not working. You're actually going to see it too. You can even do it, if you're truly attacking it, you can do it with tape. Put enough tape or anything in between.
Right.
Yeah.
Good for anything.
Yeah. Skiff locks. As we were talking about here, again, they even changed the requirements now. There's the new locking regulations on skiffs. It used to be classically, we just stuck a combination lock on top of the door and vaulted the space like this. And so if this was locked, you had this little life safety pin that you had to push in, but if this was locked, you had to turn this knob and then turn the regular handle. The gold standard now for life safety is single path unknown egress, so that you should have no knowledge and be able to egress that space. So now they've gone back, they've done a lot of engineering, done a lot of testing, and this is what's called the 2890B lock. This actually has a crash bar. It has a single latching mechanism that is defeated when you push that crash bar, no matter where that combination lock is. So these are great locks. There are commercially available versions of this lock that say you can decide maybe you don't need the expensive, and once this, for those of you not familiar with skiff lock, the way it works is once that combination is spun off, the access control system will not work. It will just basically default and lock that system hard. Great, if I was building a server room, I'd put one of these on, because one of the things that is this is one of the most secure electric locks also. It's a fail secure, so if the power loses, is gone, it stays locked. It's got a really nice deadbolt with an anti-manipulation latch on it. So there is both a government version and a commercial version. Commercial version would be a great server room if you're not dealing with the government. And you could just put like a mechanical safe lock on it, or you could totally leave the safe lock off if you don't feel you need that functionality. Okay, so access control system. An access control system really gets down to, I think of it more as a mini alarm system. You think about if you come in your house, you unlock the door, you actually deactivate, you go to the keypad, you deactivate it, and that shuts down the alarm. So on an access controlled door, you have an alarm contact on the door so you know that the door is open. You have the keypad or you have the card reader that's basically authenticating you, just like the keypad on your alarm system. So each time you go in there, and it's just giving you a time 30-second deactivation of the alarm on that door. It also then obviously trips the electric lock and allows you in. Now the problem is if you're in there and you need to come out, you're going to sound that alarm coming out. So what we do is put a little motion detector above the door, so that shunts the alarm when you're exiting. And that's how a truly fully regulated access control door works. So it's always ready to go into alarm. And so we have actually two kinds of alarms. The first one is a forced, where there was no granted access and the door's just literally the contact is now open. The second one is a held, where basically somebody went through the door authorized and then it timed out and the door didn't close, so the door's now listed as held open. It's in an alarm state. But an access control door is really, I think, best to think of it not as just, hey, it's an electric lock, but it's actually an alarm door that's being monitored, and the state is being constantly monitored. So the technologies obviously we use for these, there's a lot. MagStripe is still actually used quite a bit, still used out at Dulles Airport, National Airport. Obviously, very easy to clone, can be spoofed, has a lot of issues. Weekend was actually one of the first technologies that was ever used. It's kind of interesting. It was designed in '76, actually, 1976. You basically have these ferromagnetic wires that are embedded into the card. There's a magnet, and that's why there's a swipe direction on these. There's a magnet in there that charges the wire with a magnetic charge, and then there's a head that actually reads that charge. So what you have coming out of the back of this reader is two TTL lines. There's a line for data 0, a line for data 1. Real simple. Remember, 1976, you know. Excuse me. So those signals are then actually sent directly back as TTL 0s and 1s, and that's how you get the card read. It's actually pretty hard to duplicate this because the spacing is very hard. They're actually embedded in a prelam in the factory in the card. And it's a pretty resistant to cloning card, especially given the time frame that it was made. The thing that's interesting is not only did this kind of card technology, I think the last one I saw around was, I actually ripped one of these out of State Department in 2001. They were using this up until 2001. Is the communication is still being used. So almost every access control reader is still two TTL lines that are data 1, data 0, and you've actually got a separate TTL line to run the LED on the reader, and you got, so you got a green and red LED wire, and then you got power. It's classic, 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 and they're finally, about 2 years ago, they finally have gotten a 485 standard out there to do secure communications. I should have brought it with me. I have a little device about this big. It punches down on a weekend line. It records all the card reads, has a Wi-Fi hotspot on it, and you can replay every card read you ever had. The other problem is almost all your fancy biometric readers are made by a third party. The third party, the only way they can talk to the access control manufacturer is by a weekend line, and it can still be replayed by this little gizmo. So this is really changing very quick. It was actually the federal government with the PIV standards that started driving this change, where they said, hey, we want true challenge response cryptographic challenges with the card. But most of the access control systems that are out there are very vulnerable to these kind of hacker attacks. Barcode. The only place I really ever see this is in the military. And it's the only common identity across all military credentials. When I say that, you know, active duty people all carry the CAC, but retirees and dependents are carrying barcodes. So you're still seeing this coming into some military installations because it's the only common identifier that's machine readable on most of the military IDs. Other than that, I really don't see much of it being used anymore. Proximity. This is, sir.
You know at the bottom, what's that?
The-
Black.
This one here?
There's a bar at the top, what's that?
Okay, that's a 3D barcode, and it's actually got like, it's a PDF, I think 417, and it's got more data like, you know, date of birth and some medical and stuff like that. Any other questions? Okay. So, proximity. The classic, if you have a classic kind of prox card, that's usually 125 kilohertz RFID. It is a simple, basically transformer. You come up to the reader's a coil, it energizes that chip, and it responds out with basically usually 26 bits, sometimes 37 bits. It's a, you know, readable and repeatable. There's no challenge response, there's no nothing to it. Yes, it can be sniffed and it can be replayed back. There's now readily available cloners at Amazon. You go on Amazon and say, I need a 125 kilobit cloner. You can buy these things for like 40 bucks now. And the great thing is they're both in English and in Chinese, you know, it's like 95% of the car technology. We're trying to move away from it, but it's still out there. See a little bit of active RFID, like what you see with your Easy Pass for parking garages and stuff like that. Smart cards, this is sort of where I live now. It's obvious we can now have an actual true processor in the card. We can do cryptographic challenge responses. We're now with ECC, we're down into like the sub-second, so we're doing ECC 256, and we're getting into like, now with the new cards and the new crypto processors, we're actually getting transactions that are pretty decent. When we first started playing with this stuff, trying to do it with RSA 2048, we were at like 4-second card reads, which is horrendous, you know, in physical access. But yeah, we're down at the point now where this is really viable. The federal government has now mandated this on all their facilities, that they actually have a cryptographic challenge response between the card and the reader, and that the systems do that. They're also checking that the lines are secure during this communication. So in the last 5 years, we've had very significant progress in the increasing and basically bringing in that whole IT security, you know, doing cryptographic challenge responses. We're doing certificate checking on the back end of the systems. We're not checking certificates when we come to the door. We're just checking. We do that as a back end process, but we are doing a true cryptographic challenge response when the cards come into the door. Do you have a question? Smartphones. Everybody wants to use their smartphones. Big problem has been Apple. Apple will not allow NFC to be used. They now have changed their policy as of July, but they're still kind of being, and mainly what's been driving Apple to get in there is higher education. They said, look, our students don't want to carry cards, we want smartphones, we want to use NFC. So they've been doing a fair amount of pilots with NFC at some colleges, but most of the stuff that's commercially available is Bluetooth or Bluetooth Low Energy. That causes a problem because it's still pretty big read ranges, and how do you select which door to go into? So most of them have like an application. You have to have like a second thing where you say, I want to go into this door. Sir?
What is Apple Pay using?
It's using NFC. The technology is there.
Okay.
It's that, see, what happened was when Apple Pay first came out, they came in there and they said, hey, we want to be able to register a credit card by basically taking a picture. And the bank said they wanted more authentication. Apple said we want to make it Apple simple. And it was like 70% of the credit card fraud was being done with Apple Pay. And so then the banks went back and whacked Apple and said, hey, you got to stop. You guys are becoming the thieves of the world. And they go, okay, well, we'll do it your way. So then Apple got very scared about letting the NFC interface. So they can, obviously, it's a curated experience. So they decide what you can or can't do with the phone and the hardware. And so they've been very slow to let the NFC interface on the phone be used for anything other than payments. So it's not a technical, it's a policy, which I'm sure, I know in the physical world we always have that problem. It's not technically a problem, we can do it, right? It's either policy or money, right? And I'm sure you guys experience the same things. Okay, biometrics. So biometrics are kind of an interesting animal, and I've been playing in this world for a little bit now. And what makes them interesting is we're kind of flipping the dynamic. You know, the other two factors are us basically complying to the machine. We have a code or we have a key. We actually comply to the machine. Now we're turning it around. We're trying to get the machine to measure us, and we're not we're giving it all these variables. So what biometrics really are is they're all risk-based decisions. There's no 100% biometric. And actually, a lot of time in a biometric system, if it's well designed, if we get a 100% match, we throw it out. And the reason we throw out a 100% match is because we figure somebody's trying to spoof the system, that they've probably gotten a hold of the reference template and they're trying to re-inject it. So it brings up an interesting thing. Huh?
The first part of that, I did not understand.
So if I get 100, so in biometrics, we're doing a measurement, right? And classically, let me see if I.
So what's the typical threshold? 95%?
Nah, it's up in the up in the 5 9s. You know, 1 in 25,000 is a good fingerprint. You know, so it's still there. So what you're doing with a biometric, and I'll just use this fingerprint, is you take the image. You map the salient data points, and then you do the same thing. You have two of those. You have a reference, and then you have what we call the probe, which is the live capture. And then you see how closely they match, and you assign a numeric value to that. But if that match is 100%, we usually figure that somebody's stolen the reference one and is replaying it. That what we want is we want some dither in that match. We don't want a 100% match. And that quite often, if we get a 100% match in the system, we'll actually throw it out as a spoof. Does that make sense?
So how would somebody get that 100%?
Usually it is by stealing and injecting the reference image into the system. That you somehow are in the middle of the system, that you're somehow injecting a reference image.
Oh, okay.
Or a reference template. That's the thought, yeah.
So you're depending upon software to say, oh, I've got a 100% match. It doesn't matter what the original is.
Right, yeah. And so one of the things that classically, and this is where you get into how you design your biometric system, but all the matches are done template to template, which is a digital distillation of the image. And you really can't reverse that template out to get the image. So what they have done, University of West Virginia and Fingerprint looked at, hey, could we spoof a match given the template? And what they ended up doing was they actually made something that looked very much like a barcode. They figured out they only needed lines that went vertical, horizontal, and out of 45. So they said, okay, we got a minutia point that's like this. They created those minutia points by making lines that were at 45, 90s to each other. So they created sort of artificial minutia points, because in fingerprint what you look for is endings and bifurcations, basically the end of the line or where they come together. And they were able to do that, but when you look at what they used to spoof it, it looked nothing like the original fingerprint. So you can't reverse out from a template, which is basically the digital map, to get the image, because it's just not enough information there.
So is there a coincidence between the FBI being in West Virginia and this? Think about it.
You know why the FBI is in West Virginia?
Bird.
Bird, right, yeah,
Yeah.
that's it.
So what was that? I didn't understand the exact context. Why?
Senator Byrd.
Senator Byrd.
Oh, Senator Byrd was a very powerful
Oh.
senator from West Virginia, sorry.
BYRD.
Yeah. So what you're always doing in this biometrics is balancing what we call type 1, type 2 errors, which is false rejects versus false accepts. So basically, if you want a system that never accepts the wrong person, you're going to reject everybody. You know, it's pretty simple, right? You know, how do you keep it secure? You know, it's the classic thing is, well, how do you keep a computer secure? You lock it in a room and don't let anybody touch it. Same thing in physical security. So what it always comes down to is managing that risk, and you know those what is your rejection rate for the amount of that you were willing to accept for the acceptable precision.
So is the ideal the middle, the intersection of the two lines?
You know, it used to be everybody talked about in biometrics what is the equal error rate, but no. Because you may decide, because let's say that equal error rate down there is at like 5% reject, right? Nobody's going to use your biometric at 5% of the time you're getting rejected. And, you know, 5% doesn't sound like a lot, but it's a fair amount. If you think about, 5 out of 100 times or 1 in 20 times that you come to that door, you don't get through it. People are going to get pretty ticked off at you for not being able to use that biometric. So really what I look at when I design a system is what is sort of the 1% rejection rate and what is the acuity of that? You know, how good is that system if I have like a 1% rejection rate? Now, one of the things that you have to be careful with, almost all the studies are computer studies. They're not live sample studies. So what that means is they actually take in the computer, they've got templates generated and they're trying to match them against, a gallery of images against a certain, they take a gallery of images, generate templates, and they're trying to match it against a specific template that they got from another image. But one of the other tricks that it doesn't account for is how that capture is done. So if you're in a lobby where there's a lot of light shining in and so you're trying to do iris, that can cause rejects just because you're not capturing a good image. So there can be reasons that you're getting rejects higher than what the statistics will say to you just because of the environment.
The system is capturing rejects, right? So you can kind of...
It depends on the system, and this is one of the problems, again, in physical access. Biometric guys are kind of doing their own thing, and quite often the way it works is it's almost a separate system. When I was at the Pentagon, we actually had to build a separate system that captured and recorded all the information. Most of the things that you see right now are literally the door, the biometric reader goes on the door, it has the database for the reference templates on the device, and then it's just shooting that weekend back. So biometrics has not been really well integrated into access control systems, to be quite honest to you. Just starting into moving down that road.
Do you have an opinion on fingerprint? How reliable it is?
So what we finally ended up at the Pentagon was we ended up with both fingerprint and iris. Fingerprint and iris are about the two best that have common standards that are interoperable. So it's an interesting thing in the biometric world. There's all sorts of weird and wild biometrics. A lot of the ones that do very well are not interoperable. You can't, there's stuff like 3D face where they're doing three-dimensional face measurements. Problem is there's no standard for that, so if that guy goes under, in the biometrics world, everybody thinks they've got the new widget that's going to make them $1 million and then they're going under. So there's also just certain people, you know, we find older women don't do well with fingerprints. They just don't have as much collagen in their fingers, don't have. Samoans have very dark irises. They don't do well with iris. A lot of times people with glasses, particularly if the lighting's not good, will have bad reflection problems with doing iris. We actually ended up where we gave the user a choice. Problem is nobody really in the biometrics world wants to do that because it just doubles the cost. But I haven't found this one true that's a good measure of every person that does it really well all the time. What I look at is, okay, it's got a reasonable match rate, like a 1 in 25,000 of a fingerprint. Then I actually say, okay, bind that to a credential. So now the chances of somebody picking up this credential and matching their fingerprint to it is 1 in 25,000. Now, like at the Pentagon, we were dealing with 100,000 people. So if we just fit the fingerprint only, we'd have like 4 people matching each other, theoretically. So I don't like biometric-only solutions. My feeling on biometrics are a great non-repudiation tool. They're a terrible identifier. And, yeah.
One of the things that I'm hearing you talk about is you're looking at it from an individual device perspective.
Great.
My understanding of this space is that we never rely on one device. It's multiple faces. So you may also have a camera that looks at you. You may look at all aspects. It's not just one device that determines yes or no for access.
Yeah, I mean, to a certain extent, yeah, I think multi-factor is the way to go. You know, and I'm particularly like either card or PIN, because remember, those are designed to uniquely identify one person only, right? But they're not real good non-repudiation tools because they're easily shared. The biometric's not a real good unique identifier. Matter of fact, IEEE used to have a biometric certification. I went through it. And one of the great things I got out of that is they said if you do a one-to-many match, you get a candidate pool. That's all they would say, is you get a candidate pool. So, you know, sort of the FBI, hey, we're trying to narrow it down from the haystack to find the 5 needles in the haystack. Then you have to mechanically do something differently to separate those 5 and figure out which one is the true. That's not how, and I think it's unfortunate because the biometrics physical access industry is working really hard to sell their stuff, and that's not how they're selling it to the public. And I think they're actually doing themselves a disservice because they're, you know, you start saying, hey, you got to have a $5,000 device. No, actually you need like 2 of them. Well, maybe you need a $5,000 iris and a $2,000 fingerprint. You come up to a security manager and he goes, I can't do that. You know, I can't do another $7,000 on that door, you know. So that's been the problem. My feeling is the only true way, if you really say, hey, I want a biometric authentication, is you got to have multiple biometrics. And it's kind of interesting, you're starting to see that on the phones because we're starting to see phones with both fingerprint and iris on them. So that's also going to be in a very, phone is actually, you know, like in everything, right? It's really changing the dynamic for physical access because not only is it preventing us with a device that has multiple biometric authentications, and most all of them have one, it's driving down the cost of the imaging and capture solutions because those are becoming commoditized. So I expect, if there's some smart manufacturer out there, that they're going to start figuring this out and they're going to start capitalizing on what the phones are doing to drive down the prices on biometrics.
Where does palm scans fall in the order?
Say again?
Where does palm scans fall in the order?
Okay, so hand geometry. So there's 2 different things. I think what you're talking about, did I take it out? I took it out, I'm sorry, because it's actually basically fallen off the scale. So there was classically, you see where you stick your hand in, right? That's not actually a palm. So palm scan in a true biometric is just like a fingerprint read. I've only seen that used in forensic biometrics. So criminal, because there are states now that are capturing, and the new FBI system will actually accept palm minutia. So it's basically the fingerprint.
So the data center, that thing I'm sliding into isn't a palm scan.
It's not a palm scan. What it is a fingerprint geometry. And it's actually measuring basically a 1D image of the fingerprint. It's 9-byte template.
Oh, wow, so it's low.
Yep. And that's why I think Ingersoll Rand actually stopped making them. And then they actually started having a problem where the platen would flex and it would actually start changing it. So as these things got older, people would keep lowering the standards because they didn't realize it actually had mechanical flexing in the platen and was actually causing more false rejects. So hand geometry, I'm pretty sure that Ingersoll Rand has stopped selling it. They've switched over to sell it. For a while they were selling both fingerprint and the hand geometry, and I think they stopped selling it now. That's why I don't have it in here. Okay, eye pattern. There's sort of two things that have been talked about in eye pattern. The first one we talked about a little bit is iris, and that's the classic. That's the front of the eye, and it's this colored part of the eye. And basically what happens is the iris is formed up as a solid color in the womb. And then as you grow inside the womb, as the eye grows, it actually causes little micro tears in the colored part of the eye, and that's what you measure is those tears. Once you're born, your eye never changes. That's why you can basically see, and you don't have to refocus your eyes every so many years, or maybe a little bit. But so iris is really good. It's very stable, obviously, because it's how you see. It can't, measuring it and taking pictures of it has to stay the same, whereas your skin has to move and stuff. So it's an easy thing to image. It's very accurate. Early on, we saw a lot of things where we were doing retina, which is actually the back of the eye. Some people claimed it was more accurate than iris. It was very intrusive. You had to actually stick your eye up to it. The other thing is, it actually changes with medical condition. The one I heard was a guy was talking about, he was at one of the intelligence agencies. They were early on using this, and they started having, finding out that it was a very early detector of women being pregnant.
Wow.
So that was not real good because, a woman would walk up to it, and it was as early as like 3 or 6 weeks they were knowing, that their retina stopped working on the scanner. I also was reading that now they can even detect some stuff like AIDS and stuff like that from the retina. So it's really fallen out of favor.
They use it, I go to a regular checkup for consequences of diabetes. That's what they're looking at.
Right. Yeah. So I don't see it in security anymore. We use the iris. I've used devices that image at 6 feet, that they can actually capture somebody in a wheelchair to like 6'5". So iris has another advantage of you can do it at a standoff. I've even heard of stuff published where they say they've done captures out to like 40 feet, so you can capture it at a distance. So it's a good, accurate, non-contact biometric. Again, like I particularly heard with Samoans, their iris is so dark it's very hard to measure. So there's always something that causes problems. Voice pattern. I have not seen this used in physical security. There was some Israeli company that was at one point talking about it. I hear about it more on the forensic side, the criminal side, particularly when I've heard it more where they're trying to figure out, if this guy's talking to this guy, which are, they're trying to differentiate the two voices, mostly on phone conversations and stuff like that. Keystroke. we looked at this. I thought it was pretty neat. I actually had a reader with an embedded Linux processor on it. I thought, oh, this is going to be great. I can actually do a biometric by having doing card plus pen and then the keystrokes. Turns out you need about 15 to 30 keystrokes. So it's a lot more. It's even more than like most people do with their password. So usually it has to be like a separate sort of like, and you know, it's a passphrase you have them retype. And then the rhythm is pretty good. Again, this is not, you know, this is like at the 99.9 kind of time things that I've seen, 99.7. It's not as good as iris or fingerprint. It's a behavioral biometrics, which are inherently not quite as good. But it does definitely, I think in logical security could have something to play. You know, I think it could definitely be something that.
So, Roger, what is it about keystrokes that's unique to individuals? Is it like hunt and peck, your rhythm?
Yeah, it is. Basically, it's both the timing between the keystrokes and the dwell on the keystrokes. And particularly something like a password, you'll pretty much, you know, if you think about it, you kind of just shoot through that pretty much the same every day. The problem is you need that like 15 to 30 characters.
To me, that seems like that would be changed based off of your mood.
Yeah, I mean, it's not super, again, it's, you know, back to this gentleman's point, it's a concentric layer of security. It's not the only layer of security, it's a concentric ring, and it's better than nothing. You know, this is what the people told me. I have no deployment experience with it, so I don't know. That's what I'm hearing.
Practically, you need to put keyboards out, and you know, that raises complexity and maintenance.
Well, yeah, on a physical security, but logical security, obviously, you're using a keyboard, right? So there, it becomes a no equipment solution. I think I think particularly for you guys, it has a big benefit, sir.
There's been banking applications where they've used this for counter fraud detection. There is also countermeasures that's available as a Google plugin if you don't want that to happen as well. Basically, what they do is they randomize the timing aspects of when the keys are registered with the JavaScript to basically defeat that approach.
Okay. Yeah.
And I think like 80% acceptance is good enough for people to recognize something now.
Yeah. Like I said, it wasn't super high, but it was a range. You know, I always look at concentric rings. Face is getting really good. So in face, there's sort of kind of two things that I look at. There's what I call compliant, where you actually have an expedited reason to get you through that thing. Classic one is border crossing. You want to clear customs in an expedited manner, you're going to look square on at the camera, you're going to allow it to capture both eyes, and that's classically, you need to have both eyes to do facial recognition. You can set it up where there's an uncluttered background, and you control the shot. That's getting really good. It's getting almost as good as fingerprint. You're spending a lot of money on it because a lot of money is going into automating border crossings. The sort of face in the wild, you know, the Minority Report kind of thing. Hey, we got a camera here, and we're going to, you know, pick Bin Laden out of the crowd walking through. It's still pretty bad. That's really not there. It's really, you know, and I think it's going to be a long time because that's a very hard capture. Some of the stuff that some of these criminal, you know, when they get a really, you know, like something like the Boston bombing, some of what they'll try doing is actually artificially creating, if they get like a side shot, they'll artificially try creating the other side of the face to see if that possibly is the person. Obviously, it's not like a real-time matching, but the ones where the person has a reason to be compliant to kind of expedite them through, that's getting really good. There's sort of a third category now we're getting into where there's sort of, I would say, a kind of an implied compliance or a distraction to, so you're going down a hallway like at an airport. The classic one I think of that they did a study on. You're going down the escalators, at Dulles Airport, how you go down the escalators to security. So one of these guys said, okay, we got to get people to look at the camera. So they put a picture of a woman in a bikini on the beach up on the on the thing, right? Hey, we got to get people to look at the camera. The interesting thing, they figured, hey, we'll get the males with that at least, right? Well, they found that the women looked just as much as the men, So it was actually even better at getting that sort of faked compliance or, just distracted compliance to do some facial recognition. Sorry.
I'm reading that facial recognition is not capturing, like, when the lady gets up in the morning, she doesn't have her makeup on.
Right.
Is that just poor quality of facial recognition, or would it fit into this model?
Well, can you talk about what is facial recognition, right? I see, is it distances? What is it? Because makeup should not affect that.
Right. It is looking at the geometry, and it's usually a lot of it, sort of the first one usually is the interstitial between the eyes measurements. And then there's some, like, they try to eyes to nose measurements, eyes to ears, and, facial parts of the face that they can recognize. There is no common template, so we don't really know what each manufacturer is actually considering an initial point. The other thing with face is it works better the older you get. So it's almost impossible to do with babies, because there's just not enough differentiation in the face of babies. Sir?
I was just curious, how does this work with twins?
I've heard various reports. I don't know that they've done enough studies to really,
What's the question?
how twins.
Oh.
And again, I think it will work, again, better with twins as they age. Because, they tend to have, differing looks. If you get 2 3-year-old twins, they're a lot harder to see the difference in than 2 7-year-old twins. And then 2 adult twins are actually, usually you see more differentiation. The couple of people that I know that were actually twins that tested this out, and that's mostly what I've seen is sort of incidental. They've said they've been able to have differentiation, that it has not recognized one as the other. That's what I'm hearing is basically in adult age it's pretty good. Sorry.
Just a side point on this. The other issue is because of privacy concerns, it's really hard to do live studies on this type of stuff as well. So it's really the difficulty with biometrics, particularly when it comes to photos, because your face is considered PII in certain contexts.
Right.
You have to be very careful about how the studies are actually performed.
Yeah, and particularly you have to be careful if it's a U.S. government funded study.
Yep.
Of course, there's been some independent universities that have done some stuff, and there was one that came out about how much they could do facial recognition off of people's Facebook profiles. And if you start looking at what Facebook will actually kick back on you or your image and say, hey, you were over here, weren't you? There's definitely, there's nefarious uses for all this stuff. And facial is definitely, there is a lot of questions about it. There's a lot of people concerned about it legitimately. And the U.S. government in particular, but all over the world, they're putting a lot of money into it because of the wanting to automate border crossings, and it's the only standard biometric required on passports, this facial image. Okay, talk a little bit about safes. So safes basically come in ratings for what type of attack and how long they can resist that attack. And then somewhat about where they can, whether it's just the front and the door or the whole container. The basic answer on safes is whatever your insurance company requires is what you get. So usually you get, if you say to an insurance company, I am storing, you know, $30,000 in cash, they'll tell you, well, for us to insure you, you got to put this type of safe in. If I am storing, you know, 10 liters of methadone, they'll tell you, hey, you got to have a pretty good safe, you know. But yeah, usually safe is really all it comes down to is who's insuring you and what their requirements are on that safe. Big thing, if you ever get to a point where you have to put an asset in a safe, and make sure whoever's insuring you will insure you for that. Which sort of drives us to the next one. The other big thing you got is fire safes, excuse me. And these basically get rated as two different types of safes in fire. They're either what we call a record safe or a media safe. So record safe is paper. It allows the internal temperature in the safe to get up to 350 degrees. So that is the first number on the UL rating is obviously, that's the internal temperature of the safe. Now you get done with 4 hours at 350 degrees, that paper is going to be brown. It's not going to look like it did when you first got it and put it in there. But that's how it's designed to, basically maintain the record. It's not going to make it pristine. The other one is media safes, and basically they go 150 degrees. Now the thing you got to watch with media safes is a lot of media safes, the way they keep themselves cooler is they actually have water packs in them. So you're saying, oh, I'll just get a media safe, put papers in it because it keeps it cooler and they'll come out nice and clean and white. No, they'll come out all whipping soppy mess. There was one guy that talked about a guy got a media safe because he had a stamp collection.
Oh.
Then he had a fire.
Yep. So you can imagine that was not a.
So what happens? So what happens?
Yeah. People get the wrong safe for basically. It's even like some people, particularly, they say, "Oh, I got some art in my house," and then they say, "Hey, I'm going to get a safe for it." Make sure that, hey, you contact the insurance company and find out that they'll still, they may actually insure you for the art on the wall, but not for the art in the safe. As weird as that sounds, because you got the wrong type of safe or a safe they didn't approve of.
So there's media, the water packs that, as part of their function when it gets a lot, they burst?
Yeah, basically.
So in other words, your discs or whatever is going to be media, which can be.
Yeah, so you got, and that's a good point, because the media safes were originally written around mag tape. They weren't really written around hard, and I haven't seen anything about hard drive storage and what is a good safe. I was thinking about that last night. It's like, wow, because who backs up to mag tape that much anymore? It's mostly people backing up to hard drive.
Well, as long as they're not active, the water shouldn't hurt them.
Probably, yeah. It's a good point, And there are some, I believe, media safes that aren't water pack types, So it's definitely something I would have a conversation with the safe company. If you're going down that road of putting your backups in the safe, make sure you know what that safe is and how it's going to maintain its fire rating, and what it uses. Because, you can do it with, classically what they use is just drywall. They put a whole bunch of drywall and then just put sheet metal or some sort of a fire insulation, very much like drywall.
Something not flammable.
Right.
We used to have a fire safety, used to look like a pretty big fire gas, but weighed like 700 pounds.
Right.
And I think the sides were full of like cement.
Yeah.
Or drywall.
Yeah. But find out, if you don't know, be aware that that's a lot of how they do make fire safes to get them down to that 150 rating. Yeah. Okay. Barriers, it's pretty simple, basically we're trying to restrict or impede access and also define boundaries, and then deter things. You know, we look at like perimeter, exterior, even interior. You know, hey, should you put that server room with an exterior wall, or should you make the exterior of the building, use that for offices, and you also put sensors in there so that if they breach an office, you have an alarm that starts the time to do a response force so that they don't get to your server room. You know, look at those sorts of things in your security design. Everything can be defeated. What we're trying to do now is just give it enough delay so we can get a response force there. Actually, if you look at vault construction, it's getting lighter because the sensors are better. We're actually not trying to build a vault that can resist, you know, back in the old days when they had these 3 feet thick doors, and those vaults are still around, but they're not building them like that anymore because they were trying to resist for hours and hours. Now, we're trying to get, 10, 15 minutes of resistance so that we can get the response force on the site, the cops. We're just trying to get it, enough resistance, enough barriers, and have that detection of that intrusion so that we can get the response force before they get there, before they can get to the asset. We're not trying to protect that just massive onslaught for hours. I don't think I've seen, I guess I've seen some, doors that are attack resistance to minor hand tools for over an hour, but most everything I ever see is like 10, 15 minutes of resistance. That's all we're trying to get. Obviously, outside you see these things like, passive structural barriers and then active structural barriers. Active structural barriers come with a lot of liability. I guarantee you will jack up the car, and depending on where you're at, you may be the Minister of Defense for Japan. It's not a fun time. You will definitely, and you always seem to jack up the Mercedes, not the Toyota.
I hear that those can Mack truck and go, I think, pretty fast, and let the little dead stop it.
Yep. So this is basically what you see is the Department of State was the first to rate them. Great segue, the next slide. Thanks. I'll give you a dot later. So basically the Department of State rated them K4, K8, K12. It's about the vehicle speed, and it is also about how much weight is on the vehicle. I think it's a 50,000 pound vehicle, and that's what it will stop it. This has now been changed over to ASTM, and they actually have more categories and more. I think they're still at the 3 different speeds of 30, 40, and 50 miles an hour.
They're pretty good then.
Yeah. And most places do put in a K12 because everybody is scared. Hey, what are we going to put in? I'll put a K12 in. Only time I see stuff that's not K12 is usually really tight space, like downtown, and they know that the person's going to have to make a turn to get into it, and they'll sometimes drop the speed. But yeah, the barriers, they're no joke. They're a serious.
The mechanism to make them go down might be probably the weakest link, though, right?
Yeah, I mean, and that's also gets to be hard. Classically, they start off with hydraulics. That's really a hard maintenance-intensive system.
Like the remote or.
Well, what really caused a lot of problems was the hydraulics, because you got to remember, hydraulic fluid gets thicker in the winter and thinner in the summer. So you're really putting a lot of stress on that hydraulic pump. Now most of the newer stuff, what they're doing is they're going more to like a skeleton and steel frame instead of a whole slab. And they're using electric motors and just gear reduction motors. The other thing that's a real problem with hydraulic barriers is usually you've got to use some sort of vegetable oil based product, which is very expensive because you don't want to have a hazmat situation if any of that hydraulic fluid leaks out. So hydraulic barriers are a real pain in the butt. It costs a lot of money to keep running over the years. And then there is just the factor that you have a pit, so now you got to drain that pit and keep it sumped out. So yeah, a vehicle barrier is a lot of maintenance.
Is there also a problem that most time they spend their lives down and they don't almost never get raised? But then something
That obviously, if you don't use it, then that causes problems.
Do you have to exercise it like quarterly or something? Is that like a thing?
See, I've mostly dealt with places where they actually did move them up and just drop them.
For the whole,
They were always using them. You know, it's just like leaving a car not to run. You know, yeah, if you leave it, you don't know what you have if you just leave it in one position, because you get rust on a piston, and then it tries to go through it. And it may work fine for a bit, then that rust wipes out the seal on the piston, and then you got all sorts of trouble. And you try to hit your emergency up, and it won't work because you're just blowing hydraulic fluid past your seal. Yes, it's a mechanical device. It's bound to fail at some point. Okay, I think I'm at the end of my presentation, and this is me. Sir.
Back to the biometrics.
Yeah.
Overall, the idea, I think you had a word for it, or they're a secondary factor.
I think they're a great non-repudiation.
Non-repudiation, yeah, because how do you revoke a biometric? What if my fingerprint gets stolen? What if my face is cloned,
And again, this is some of why we reject the 100% match, is we figure somebody's stolen the reference. But yeah, it is a non-repudiation tool. It's not a real good identifier.
Okay, so you use it to identify a candidate set or to validate a candidate is in that set?
Well, so the two terminologies they say is a candidate pool or an identity verification is the way IEEE says it.
Okay.
So if you say, okay, I have the credential in a two-factor, you're doing an identity verification. If you're doing it just as a one-to-many, now I'm not saying that one-to-many may not be a very legit. If I was running a gym, right, I'd be pretty happy with a one-to-many biometric, because I figure, hey, what's my downside if it doesn't, somebody spoofs it, right? Somebody gets in my gym, but and it's going to have a pretty good deterrent to, versus like somebody passing a credential or something like that. And I mean, Disney saved horrendous amounts of money by implementing biometrics. Just unbelievable, because what they were doing was they were buying the multi-day passes, which are about half the price of a single-day pass, and the bus drivers were actually selling them. So they basically, the bus drivers told the guys, buy the 10-day pass, I'll pay you for all the days you don't use it. And he sells them to the guys going, he's driving back out, right? Yeah, so Disney is like, hey, if somebody doesn't match and I let them go through, it's not that bad, but the perception was such a great deterrent,
Okay.
Yeah, sir.
So my phone's encrypted, so they say.
Yeah.
I got a fingerprint reader. Am I fooling myself about how secure this is?
In fact, not just phones, but laptops as well.
Well, just stick with this.
Well, is it Android?
Does it matter?
Well, Android doesn't get patched traditionally, so your operating
They gotta
system.
Google, so it depends on where you're getting
Have
your
a
phone
Google
from.
phone, so they get upgraded.
They get
faster than
upgraded.
most.
Okay, yes, they do.
But anyway,
So,
here's a benchmark.
is it attackable? Absolutely. And is it attackable, and what is that attack? So they have to acquire some way of basically, modeling your fingerprint and replaying that back to the sensor.
You're talking about how precise it is, meaning how
safe.
unique it is. Well, that's a different question.
So the answer is you're probably, well, you got two fingers in it, right?
Yeah.
So you figure a single finger is about 1 in 25,000, so you're about 1 in 12,000.
I'd say, what happens when you fail to off with your fingerprint?
Right, and that's, again, that's just like...
You're not erasing it after like 50 attempts.
Yeah.
And, shame on you.
Well, but after so many failures too, it like,
Time.
it slows you down and then it'll eventually.
What are you securing? What is it worth?
Yeah.
Second question.
There's always an attack,
Yep.
and it may not be the way you think.
Right.
How do you protect your solid state information on your computer and keep it safe from fire?
How do I do it?
Yeah.
I just stick it on a hard drive and stick it in a fire safe. But mine doesn't have water packs in it.
Love that story.
Do you RFID into your house?
Do I RFID into my house?
Yeah.
No.
You got one of those weak locks?
I got a Yale Real Living electric deadbolt, and so this brings up a kind of
3-inch screws on it,
well,
on the strike.
right, very good point. You know, I could have a great lock. I started off, I actually had a medical lock. Okay. Of course, the one thing that happened when I looked at my house, the latch plate was. Yeah, well, it was. I actually have an older house that actually has this. Believe it or not, it's a brick on block fascia. So it's got, but then it's got the door frame, which has got the wood, and it gets framed in there. And I didn't see a lot of good stuff in there. So what I did is I actually pulled out the stripe, shot a tube of PL bond in there to get that all bonded up. Now, if you ever talk to guys like on a SWAT team, one of the things they'll tell you is that half the time he'll breach door hinges.
Short screws.
Yeah. So, you know, you need to, if you're really looking at the attack resistance of the whole system, you need to look at, like, hey, maybe go ahead and PL bond your, hinges. I probably should do that. I haven't done that. Don't come to my house. The thing that happened was about, let's see, now it would be about 6 years ago when my daughter was about 7, and she needed to get into the house by herself. Knowing what I was as a kid and how many keys I went through as a kid, I started realizing that this medical lock, although secure, was probably not going to be a good risk as we start losing keys. And so I went out and bought a Yale Real Living combination deadbolt, and that is it's still rated as a UL grade 1 deadbolt. It has a nice advantage of it actually relocks itself. It's an electric drive deadbolt, so it relocks itself after 30 seconds. So even if my daughter closes the door and doesn't swipe it to relock it, it locks in 30 seconds. So even though it's probably not as attack resistance from the, because it's now just a combination, it's probably overall giving me better security. And it's one of those things you have to look at and do a risk assessment on. There's another question?
Can we mess with this stuff?
Yeah,
please do.
Come up and check out the labs.
Yeah.
Thank you.
Yes.
And as I said at the beginning, anyone looking for a job, anyone looking to hire, hang out over here, and hopefully that'll do something.
Hello again.
Would you send me the slides or send them to him?